Welcome to Retro Upgrade. This time I'll be showing how I designed the fan shroud for my new computer. If you haven't seen it, watch the video. I'll put it in the link. It turned out great. I followed a small guide from MangoJelly, how to make hexagons. I'll be using FreeCAD. It's a free alternative to Fusion 360 because Fusion changed their policies a while ago that you can't do commercial work with it. So that means actually no YouTube if you get paid. I'm still not getting paid from YouTube, but I will get there eventually, hopefully. So I already done the shroud. I can show you here. It turned out great. But just to show you how the process goes of building this, I'll start from scratch and then show you you can actually change out the hexagon shape to anything you want. And that works great as well. Okay, so let's go get started. So I was thinking about 3D printing as well when I designed this. So I wanted a flat area to print from, and yeah. So you could make your life easier if you have a liquid 3D printer or something. Okay, so let's start with creating a new sketch. So the difference between this and Fusion is that this has more features and it's harder to use. The learning curve is harder actually because it has everything Fusion has and more. Also, you have presets for the shortcuts and stuff. I use the Blender ones because I'm accustomed to them. If you're used to, let's say, Fusion, you can just use the CAD one. Okay, so let's go. So first step in this is actually choosing the workspace. So there are a lot of workspaces here and you can actually add more. There are plugins you can use. But the most used workspaces for us that make stuff for 3D printing and stuff are Sketch, Part Design, and in my case, the Draft and Drawing as well. You can do a lot of crazy stuff here. There are a lot of videos. Like I said, MangoJelly does a great series on how to use this program. It was practically unusable until version 20, and you can see it was not long ago. So they improved it a lot. But it's fully featured. It even has simulation and stuff. Okay, let's get going. So go to Sketcher, create a new sketch. You see everything else is grayed out. I can actually turn off the AIO because you can have multiple projects at the same time and link them together and stuff. Okay, so this is an unnamed project. Let's rename it. Just double click or right click. Okay, no, this is based on save. Sorry. Okay, so just let's click and create the sketch. There we go. Okay, so let's make it easy for ourselves. Let's do some slots. This is the slot tool. I'll just do this and this. I clicked on the line, so it constrains it. Redundant constraint. So we need to check which one that is. So this works a little bit different from what you're used to in Fusion. It uses constraints. You can see it's white now. So that means it's not constrained. So I can move it around. See? But it's constrained to the line. So it slides along the line. So what you need to do is constrain it so it's fully constrained. You have 3 degrees of freedom here. So up and down, left and right, and tilt. It probably has one more. I can't really figure out which one. So what you do here is you use the constraints right here to keep it still or to keep it in place. So first of all, let's give it a size. So let's say you use the different ones, height, width, and you have a length. So the constraint from here, from here to here, you have the millimeters, and let's make this 3 millimeters. Not 33. Okay, that's a small slot. If you want to use hexagons, you just use hexagons instead and constrain them. And then we have to do the width. So to constrain it. So there we go. Or I think the width is calculated with the height. Control Y. I screwed up. Okay, and you want to actually measure out how long, where you want it placed. So let's say I want from here to here. You don't need to use control to multiple select in this program. You just click and you click here. Let's think a bit. How much do I want? It depends on the actual width of everything. So let's say 9, I'm guessing. And let's put this to 9 as well. 9. Okay, so we have a slot. And we want this repeating. So what you can do is just draw a new one down here. Free. It's give it the same dimensions. So there. Let's pick this to this. 3. And 9 and 9 is 16. So or 18. Sorry. There we go. From here to here. 18. So this is the same. So what you want to do is stagger them so you can tile them. So let's go. We need to. You can also use the what's it called parallel. So I want this line parallel with the horizon. There we go. It's over constrained already. So over constraint means it has too many constraints or redundant ones. So you can just click there and press delete, and it deletes the constraint. It still has 2 degrees of freedom, so I'm guessing, yeah, it can move around. So what you can do is make construction geometry. So let's say you put a line straight down. I'll use this, and one straight out. Okay, so we'll be using these lines to place this slot. Okay. So let's give this length. No, length, please. There we go. So considering this is 3 tall, we need some space in between. So let's give it, let's say 7. Okay. No, that's too much. So let's go to 5. Yeah, that looks pretty good. And then we also need to constrain this. So how far out? So let's say from half out here. So actually it will be at the same point as this, so 9. So let's take this 9. It was almost there. And now we need to put the center of this here, but as you can see, there's no center point on the slot. So what you do is you take this, use this and this, put a length constraint 9. That's pretty close. And if you want, there are 2 ways of doing this. So you can use the point constraint. So you can choose 2 points to go together like this, but it over constrains it. So that's not a good idea. So go back. So instead you use a length constraint from here to here, from this, or I think that's the constraint. Yeah. Or you can use another type of constraint. There are a lot of ways of doing this. This is not the only way. So I would like to use the point constraint, but it seems it over constrains things. So if you do this, it should work, but it doesn't snap to it. So Yeah, I did something most of you will do. So I screwed up. I held the middle mouse button and moved. So just use this to re-navigate. It's control middle mouse button to move, or shift middle mouse button to move in Blender. Okay, so instead of using that, we're going to use this constraint from here to, no, it doesn't really want to. From this point to this point. And we used 5. There we go. So now it's fully constrained, but we have these lines and they're going to show up in the extrusion. So I don't want them. So what you do is you select both lines you don't want, set them as construction geometry, like you can see here, and they turn blue. So these won't show up. Okay, so this is actually all you need. So the reason I didn't use hexagons this time is because I can show you you can make rocket ships and stuff and just put them side by side and do a repeating pattern. So you can make whatever you want. I could have made my own logo and stamped it on. It takes time, but you can. You can also import SVG files here. Okay, when you're done with this, you have to close the workbench. So that's another thing that's different from Fusion. You have to check first that it's fully constrained. You can see they're all green, and it says fully constrained here. So that means it's okay to leave this work area. And you can see them here. So let's spin this around. This is what's going to be repeating pattern. So in this case, we don't have any tools to array this. So you use arrays to place them in sections. So let's go to the draft. We don't need the grid because it doesn't match really the size we have. So we just close it here. And the really good part of this is you can always go back to the sketch and change the dimensions and it works. It just works. You don't need to worry about anything else. You can also use a equals, let's say equals operator. So it both stay exactly the same size. That also works. I'm used to putting dimensions on everything, so it doesn't really matter. But yeah, of course, if I change one, I have to change the other. Now let's click the sketch, go to modifications, array tools, and array. You all have different kinds of arrays, but this is the one I used. Now let's see. Okay, so I'll do this. I'll put this at 1, just not to get confused. I'll show you how you change these values from another place that you can see the results directly. Because as you can see, nothing changes. So press OK here. And now you get the data. And you see the sketch is gone. It's inside the array. And it did a repeating pattern way too far away. So what we need to do is give it some values. So you go into the orthogonal array. So that's the tool. This is actually the tool data. So you can choose and change stuff. But usually you just work on the bottom part of it. Okay, so let's go. So the X interval, that's what's important. You see it's set to 100. That's way too far. So it's way over here. And I have 2 repeating. So for the X. So what you do is first you set up the length and then you do the repeating how many times you want it. Okay, so let's put this to 9. That's too close. 9 by 2, 18. They're still overlapping. Oh yeah, we use the endpoints inside. So let's say 22. That's a little too close, maybe, because we need to print in between. That's going to be a little too close together to get a clean print. There we go. That looks about the same distance from here to here, that from here to here. Maybe 23 will be better. Yeah, 23 is closer. Okay, and now you can just change the repeating steps. Let's say 6. Click away, and you get all 6. So let's zoom out. And you have to repeat for the X, or the Y, sorry. So you put Y to 2, so you get a repeating pattern. It's way off, I'm guessing. Should be here somewhere. Oh, on top. If you lose your controls, just click on the array and you'll get them back. Okay, so let's go back. And this time the interval for Y. So you see it's really far off. So what you can do, instead of doing what I did, you just reduce this with the pointers. Click off. Okay, not that way, but click off and then keep going until it's close enough. You can do this with math, obviously, but this is a lot faster. There we go. That looks really nice. And this is going to make a slotted effect on the shroud. Okay, and we need this repeating. So, okay, I screwed up. You don't use the scroll wheel on top of things here. You just change stuff. Okay, there we go. I just wanted to see if I didn't screw up anything. I didn't. Okay, so I need this repeating up as well because I'm going to make a shroud, a circular shroud. So let's say 6. We'll see how many we need in a while. When I make the actual cylinder, we'll be cutting out. So what you need to do is now extrude this. But you can't do it in this workbench, so you have to go to another one. I use the parts workbench for this. You can also use parts design, but I use the parts one. You choose the array. You choose extrude. You give it a height. In this case, it has to cut through the top lid. So or the shroud. So I'm going to make geometry it's going to cut away from. So you need to think about the thickness you want. My shrouds on the AIO are 3 millimeters thick, so I made this 4. No, not 40, 4 millimeters. There we go. So these are not 3D, as you can see here, and that's a nice little grid. You can always go into the extrusion and change the size, the pitch, and everything. So that's what's different from Fusion. Normally, when you go in and change the first sketch in Fusion, you break everything. And that sucks really badly. Okay, so let's make this cylinder now. I'm going to be cutting away from. So I'll press cylinder here. There should be a cylinder somewhere, right there. You choose to the radius. We know the radius, it's the shroud diameter, and the shroud was 120 millimeters. That's the external diameter of the fan housing standard. As you can see, the actual thingies are the slots are way off, and there are too few of them. So. And let's change the height of this because this is the thickness of the actual shroud I want. So 3 millimeters. So now we can see these. We can also do a transform operation on the cylinder. So you right click the cylinder, transform, and we can move it to the side here because it expands this way and up. So we do this. Okay. Sorry if I'm explaining it a little rough, but it's hard to explain CAD software normally for me. So, okay, I have placed the cylinder where I want it. So let's go back to the array and just pump up the values. So I'll need a lot more of these. Next. Okay, that's too many. It's trial and error mostly because you can do it with math, like I said, but It's way faster doing it by hand. So 10. Yeah, that covers the entire circle. And the Y will need about 10 too, right? It's circular, so should be no double at least. It's better to go overboard than to go under. I forget to click off. So if oh crap, I clicked the wrong one. If you did this in Fusion, I've already tried. It hangs because it uses an online thing to calculate stuff. This is really rough for Fusion. Let's put 11 here. Move the cylinder to the right. There we go. You see, it takes a little while, but when it's done, it's not bad. It moves. Okay, so let's just center this, and we transform the cylinder again. There we go. That looks pretty promising. Now, in the parts workbench, I don't know if you have Boolean operations here in front. You don't, or I don't think so. You press OK again. And don't forget to press OK here. It's a recurring thing. It's one of the annoying things, but it also makes sure you're done with the tool before it kicks you out. Okay, so let's try this. So you go to Boolean operations in parts, Boolean operations, and then you have Boolean cut. This means we'll cut away one of the things. And normally it cuts away the first thing you click on. So if I click on the extrude first and then select the cylinder, you have to hold control. You have select them in a order. So let's go into Boolean. Let's go into Boolean and cut. This should make okay, no, it cut away the cylinder from the bottom, as you can see here. So you have to choose it the other way around. I'm used to other tools, so it happens. Okay, so you choose the cylinder first. That's the main body. And you want to cut away the extrude. Okay, that's how they did it. Okay, let's try again. It takes a while, but when it's done, it looks amazing. So this is the new shroud. This looks good. But as you can see, these corners will be a pain in the ass to print. And so what I did was, okay, I know how big the fan is on the outside. So I made it so it interfaces exactly on the lip of the fan. So we did this. I used that tube. I did 100 and no, because it says radius here. I really don't like that because they should use diameter, but fine. Radius is just a half of the diameter. So 120 becomes 60. No, doesn't? Should. 120? No, 240. Sorry. Radius. Am I thinking wrong? Oh, no. That's right. I'm dumb. Okay, so this should be the same, 120 millimeters. Oh, so this is too small. Did I screw up? Okay, let's go to the cylinder. Radius. Okay, so I screwed up. So radius is, let's say the radius is half of the diameter, right? So the diameter is the correct value. So I should have used 60 here. Okay, there we go. I screwed up. just because radius and diameter, you use diameter in the dimensions, so you get a little screwy. Okay, so let's start over. So 60 is 120 in the diameter. Radius counts from here to here, and diameter counts from side to side. Okay, so you need the inner diameter to be as thick as the lip on the fan. In my case, 2 millimeters. So it's 60 minus 2. So if you are not sure, you can always make a formula. So 60 minus 2, you have 58. So you can use math actually in here. And you can actually reference other objects as well. So I can actually reference the cylinder and use that if I want to. This will make a tube. Like you can see here, it's an outer ring for our shroud. And we have the shroud plastic is 3 millimeters. But I don't want the shroud right against the fan because that would make it rub. So I want a few more millimeters. It just sits on the fan lip. That's the outside plastic that's holds it up. So I want 2 millimeter distance from the fan to the shroud. So let's put 5 here because this is 3. So plus 2, 5. And now we need to move this in place. So you use the transform again. Zoom in so you don't screw up too much. This is a little fiddly. One more up, I guess. That looks about right. Yep, it snaps. I've snapping on. You can turn it off somewhere. I really don't know where, but it's kind of handy to have because you can align stuff quite easily. Okay, so this makes this. You see the small lip that's around? That sits on the fan shroud or on the fan, not the fan blades. The fan blades will go exactly inside. So this is the interface part. Now you can see these are two separate parts. So it won't actually print that well because it wants to print everything inside and out and will get messy. So what you do is you choose both. In this time, you choose the cut, that's this one, and the tube. You can rename this if you want to. You go to Boolean operations and use union. Okay, so this time it's not important the actual order you choose them because it puts them together. So just do this. Now it's a union and it's a entire piece. Ignore these. They're just there for reference. You could make the outer ring a little bit bigger. Wouldn't matter at all. Just aesthetically, it doesn't look as good. And what I did was clips. You can do this multiple ways because this is going to sit on top of the fan. This lip right here. So I did clips from the other side. So they go from the top, printed directly from the print surface. I'm going to print this flat. As you can see here. So you choose just a flat area here. You can actually just make a sketch from there. So you go back to sketch, sketch, flat face. You can bring in outside geometry. In this case, I'm actually going to use the ring, but you can see these lines here. So these are because of the slots, the interface there, and the application doesn't remove them when they merge stuff. So, but we do have some clean lines over here. So let's import those. You use this to import outside geometry. I think it says external geometry. Yeah. So I'll click on this line and this line. And now I should have them on the other side. And I do. And the reason is not to get the geometry itself. Okay, it does help, but the reason is actually to get the center point. So there we go, and I'll spin this. Okay, so it's a little confusing with the maneuvering and stuff. So what I want to do is to make a corner thing, mirror it over and mirror it over again and mirror it over there. So I have 4 clips. The clips will be on the outside because this is the actual thickness of the lip on the fan. So I wanted to clip from the outside. So, and you actually don't need to do ribs or anything. You can just do a tight fit and it will clip on right quite nicely, just like the mines did. But you can actually make small knobs or whatever at the ends of the clips to keep it even tighter. In my case, I'm the only one going to touch it, so doesn't really matter. My recommendation here is use a lot of construction geometry. You can use this so you can remove it so it doesn't get printed. So I'll click the center point and go to the inside line. I got a parallel constraint and a point on line constraint. So this is a straight line. I also want one straight up. These are for later and actually for now. This is also a parallel constraint and a point on line constraint. So this is 90 degrees. So what I want is actually a line that is 45 so I can get my part in the right place. So a line there. As you can see, it's white, so it's not fully constrained like the other two. But you can put an angle constraint here and put 45 degrees and you get it exactly at the corner. This will let me mirror it over here, then over here, because I have the mirror lines already set. We can mark all these and put them as construction geometry. There we go, they're blue. They won't interfere with the actual design. Now, what I want depends a little bit on what you want to make for clips. You can use this, you can use this, you can use anything under the sun. You can use circles, squares, whatever. As long as you can cut away the actual clipping surface, I'll show you in a while. It's fine. So okay, so let's use a hexagon or yeah, yeah, a kind of polygon. This is probably a hexagon. Okay, so I'll click the hexagon. I used a slot before on my own. I'll use this line as an anchor. Looks good. It's not constrained because the size is not constrained. So let's give it a diameter. The diameter of 12, I guess, will be nice. Yes, because it's constrained to the line. It's following the contour. You can actually just leave it as is if you want to make the clip, or cut it with this line. So you do that by using trim tool. So you use this, 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 and this. And you can see you cannot even trim away this, so you only have this line, and it only prints that. But in my case, because I'm going to cut out everything in the middle, that's not needed. So this is already done. So I'm doing it another way that you could do. This will cover up these holes as well. So maybe you can do it until this line instead. So there, 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 and there. We need some constraints. You can see it's not green. It moves. So we need to make these equal. constrain symmetrically. No, that's not what I wanted to do. So let's take this and this distance. Just set it as default size, and same for this to this, so we can't move them. These are set. Can move these around to make it easier to see. And distance from here to here, and from here to here. This is just to make a constraint. It's over constrained, so 2 degrees of freedom. It's because it can tilt. It's the height of these. So let's put 3.24, and let's make this one equal to this one. Equal. There we go. It's fully constrained. So it takes a while to get used to constraining everything. But when you get the hang of it, it's actually quite useful because you don't need to worry about breaking your design just because you change a parameter somewhere. I'll show you later. I'll change the slot spacing, and it will automatically update everything. It takes a while to update, but it works. Okay, so we are done with the actual shape we want. We also want it to have a bottom from here to here. This is just because it doesn't copy over the line because it's considered as construction geometry. Okay, so this looks kind of complex. It's not really, but it looks complex. So what you do is you choose or you select all the lines. You don't need to use control. You just press them. Select the mirror line. In this case, I'll select this one last. And use the mirror command. It's right here. Is this the mirror? Yeah. So I should have one right here. But you can see it's not really constrained. And the reason why is it's not on the actual line. So you do this. You choose the point, choose the line, and put point on line. There we go. It's constrained to there. And same here. There, there. Point on line. It didn't, or it did. It's on one of the lines. This to this. Okay, it's over constrained. So do I have 2 lines? Okay, so let's see. Okay, so that one's constrained to what? The line of the, okay. Okay, so it's constrained to this line right here. This and this constrain. Did I click the wrong line? Yeah, I did. Okay. So this is things that can happen. I constrained it to the wrong line. Right here. There we go. I constrained it to that line instead of this one. It doesn't want to. Yeah. Do I really need to constrain this? So what do I need to constrain? Okay, so it can move freely. That's one constraint we need to fix. Point on line, and it goes up there. So now it follows the line. Okay, so the line is not really where it shows it is. And let's see if I can constrain the other side. point on line. This constraint. So what's moving now? Let's see, 3 degrees of freedom. Up and down. So this and this we can make equal. Okay, so they're not compatible. From there to there. So let's see what went wrong here. So the construction the geometry is not width. Fine. I screwed up. I didn't select the construction geometry. So that happens. So let's remove that. Okay, no. There, it's fully constrained again. This time I'll select the construction geometry as well. And the points. You could probably do a selection like this. Yeah. Remove these. Now let's click this one last. This should be a lot easier to constrain. Still not constrained to the line. But this time it should be close enough. Constraint to line right there. So we don't need to do a lot of work to constrain this. So the movement pretty much back and forth. So what we can do is just take this point to this point and make a distance and just press OK. This will keep them that size apart. So there is one constraint that's not really okay. So it can move on this axis. It shouldn't. So let's do this. Use this point to this point and put one as well. Are you fully constrained now? You are. You can't move at all. 2 degrees of freedom where? It is constrained, so it's not this one. Could be my lines here. No, not really. Okay, no, just let's stop faffing around. Let's copy both of these. Choose this as the last point and mirror. So we have them all. There are 4 clips. You don't need to fully constrain anything here because we're going to extrude and move things. So you have them right here. We're going to attach them to the main geometry, so it doesn't really matter. So you choose the sketch, go to the parts workspace, extrude, Now comes the interesting part. So you press OK. These go from where you made the flat surface out. So you need to change the direction. So what you do is you choose this extrude and reverse. And press through, click somewhere else, and it reverses it. But this won't work as a clip because these will interfere with the actual. This will interfere with the fan shroud. So I need to cut away what the fan is using up. So let's do this. So this is the way I do it. You can do it another way. I'll use a cylinder now. It's way over here. So let's transform. Right click. Then new cylinder. Transform. Move it roughly to its place. There. I want to make it a lot bigger. 120 or 60 in radius. Did I get the placement right immediately? Not really. And it's too thick. So what I'm going to change the thickness again later, but I need to see the placement. So I'll make it thinner for now. Use the transform again. That looks about right. So I'll go to the or the side view. Nope. There we go. Front. And bring it up a bit. So it starts there. So it's exactly on top of where it ends. Press enter, go into cylinder options, and just extend this over the top because we'll be cutting away this cylinder from these clips. As you can see, that would make a nice clip. Go. Okay, so the way we removed geometry is press what you want as a main body, what you want to remove from, what you want to use as a tool with the control button, parts, Boolean operations, cut. Now you can see it has a nice cut right at the corner here, and it follows the contour of the cylinder. So this will already clip on really nicely. If you want a logo on this, you use the what's it called? The draft and put some text on and extrude it and just union it. You can see we have two objects here. We don't want that. We want them to be together. So you choose both, parts, Boolean, union. This is for 3D printing only. So it doesn't have multiple parts because it will try to print the insides of all parts otherwise. Now, last part, I'll show you how to make the text for this. So I'll choose the flat area on the back. Just spin this around. So go back. This time we'll go to the draft. You have the text here. Just click and drag anywhere. Should be able to input the text somewhere. String. There we go. Retro upgrade. You can use different fonts and stuff. You can just choose a font here. Let's see, computer, C, Windows, fonts. Yeah. And here you have all of them. I chose Arial, something or other. And you have bold. There we go. Let's choose the bold one. And you have the height and width and everything. You can always change it later, but this is a 2D. It's not 3D, so you need to extrude it like everything else. You can use the transform with this as well, so you can place it where you want. There we go. Press OK. Go back to the part. Extrude. Let's give it about 2 millimeters thick. As you can see, it protrudes, and if you want this as a flat printing area, you need to extrude reverse, so it uses the flat area and pushes in instead. So you go back here, reverse, through, click somewhere else, and now it's actually going in. So you can do one of two things here. You can either extrude, cut out the shape, or put it in like you did here, and you just use a union for both. I did a union, but you can actually do this, and then do a boolean and cut, and it will cut out from this the logo. It doesn't look too good, so what you can do instead is just union them. Union, boolean, union. It's still a little hard to read, but it's a lot better than the other. And now this is an entire object. So, this is where this application shines. In Fusion, you have to use an extension to export to STLs and stuff. This has that included. So you choose your body, file, export, STL. That's exactly what you need to do. FreeCAD, YouTube Designs. And what you do next is open your favorite slicer. In my case, Cura. I'll bring it right over here. FreeCAD, YouTube Designs. There we go. And as you can see, it's placed the right orientation down and everything. You slice and you print, and we're done. Pretty much. You can see a preview of the slicing and how it's going to print it. So these are all the layers, and this is actually the print moves. So it's going to. You better have good bed adhesion when you're doing small circles like these. Use hairspray or something. That will help a lot. I have a glass bed, so it's easy. You can see the print time is quite long for these shrouds. It's 1 hour and 22. It's because all of the intricate movements and stuff. And I actually have it printing really slowly at the start of the print. I speed it up afterwards. Initial layer is 20 millimeters per second, and then I speed up to 60 after the first layer. So I could actually improve this, but I have some problems with adhesion on my on my 3D printer. But this shroud should work just fine. Thank you for watching until the end. Hopefully this was useful for someone somewhere. If you want more in-depth tutorials for FreeCAD, go to MangoJelly's YouTube. They're awesome. He goes through everything and all the different workspaces and stuff. And he really knows what he's talking about. I'm a newbie at this application, so I did it my way. But it turned out pretty good. I won't complain too much. Have a nice